So here's a view of the two lasers I was looking at, and behind them are the part numbers and the packaging that came in. They both say they're 5 milliwatt. This one says Copperhead 5 milliwatt, 3.3 volt. I also purchased this one. It also came in a 5 volt version, but I couldn't really tell any difference. Yeah, they seem to perform the same. I have a side-by-side comparison of these two laser modules I'm considering to use in my project. They are projecting onto this piece of paper, and right above it is the current consumption of their module. So this is the right side module, and this is the left side module. Right now, they're running at 10.9 on the right and 39.3 on the left. And up above here, this is the voltage that's applied to each of them simultaneously. I'm starting at 3.7 volts because I'm planning to use this in a lithium ion battery circuits, and that runs about 3.6, maybe 3.65. So I'm interested to see what the quality of the beam will be and the current consumption as the battery will deplete. So I'm going to slowly ramp the voltage down now to simulate the battery discharging. And while I take a look at the beam outputs. Right now the one on the left seems to be putting out more light, but it's not quite as focused. And I'm also noticing as I decrease the voltage, the one on the right is actually the current is increasing, and the one on the left is actually decreasing and tracking the voltage. So that tells me that there must be some sort of driving circuit or a regulator circuit in the left side, in the right side, and that would explain the difference in the size. It must be inside that can there. So right now we're about 2.5 volts. The one on the left starting to fade away. One on the right still hanging in there. And right there at about 2.2 volts is where the one on the right falters and goes away. So that would be the lower limit. I would say maybe 2.3 volts would be its lower limit. So for my application, I believe I'm going to have to choose the one on the right because it's a lot more efficient and it will have a more consistent performance over the lifetime of the battery, over the course of the battery discharging. But if I was interested in just the maximum light output, I'd probably go for the one on the right because it seems to be able to be driven harder. But it does take a lot more current to do it. Well, thanks for watching. I hope you enjoyed the video, and click the like and subscribe if you want to follow along on some of the other projects I'm working on. Here's a close-up view of the laser mounted in the front of the stock and the pressure activation switch mounted there on the side.